how often do you rely on the weather? I mean, let's be honest, like we look at our local weather person and they provide the weather for us on the news, or we look at our app on our phone and we look at the app and we say, oh, it's supposed to rain today at 3 o'clock or 4 o'clock, or it's supposed to snow if you're in the place where I live in Ontario. We rely on that, but it's not always right because it depends on models, and models are not always right, but they have their level of accuracy, and weather patterns change. But we have to understand the weather. We have to understand how our weather patterns around the world affect all of us, from, just the regular person like myself who goes out and walks the dogs and doesn't want to walk the dog in the rain, even though my dogs always want to walk in the rain. I have to know what the weather's going to be like. Or if a farmer knows what the weather's going to be like coming up over the next 2 weeks or a month, or what those patterns are going to be like, they need to know what it's going to be like for their crops this year. A lot of people rely on weather. A lot of people rely on understanding the climate, and the people who understand the climate, meteorologists, and be able to communicate that towards us are really, really important. And that's going to be our focus on today's episode of the How to Protect the Ocean podcast. We have Dave Jones, who's joining us today to talk about the importance of data that feeds in to what we know about our climate, what we know about the weather, and how our climate is changing, and how that can protect not only citizens around the world, but especially citizens in the US. We're talking about cuts to the National Weather Service. We're talking about cuts to NOAA. We're talking about cuts to NASA, and how that may or may not impact the world today as we see it for US citizens and the world. I can't wait for you to see the show. So let's start. Hey everybody, welcome back to another exciting episode of the How to Protect the Ocean podcast. I'm your host, Andrew Lewin, and this is the podcast where you find out what's happening with the ocean, how you can speak up for the ocean, and what you can do to live for a better ocean by taking action. And we're going to learn all about science today. We're going to learn about the climate. We're going to learn about the atmosphere. We're going to learn about the oceans. We're going to learn about the data that provides us with the understanding of knowing so much more about the oceans that we did in 1900s, when we didn't have satellites, we didn't have buoy systems, we didn't have drifters, all these different instrumentations that provide us with data to go to the people, the meteorologists, the oceanographers, the scientists who understand and interpret that information to provide it to us in a form that we can understand and that we can make better decisions around where we live, how we're going to live, where we're going to go that day, where we're going to go that hour. And of course, there are some times when it's not right and the weather changes, but for the most part, we get to understand, especially before we had all this data. We're talking about data in climate, in the atmosphere, because it's so important, because there are cuts being made in the US where a lot of this data is funded, and especially on an international level, that could affect U.S. citizen safety in terms of predicting hurricanes and other natural disasters and wind patterns that would affect them not only in money to clean up these natural disasters, but actual safety in terms of lives saved. So we want to understand what's happening all around that. And Dave Jones is joining me today. He is the founder and the CEO of Storm Center Communications and Geolocate, which is also a company that he owns. And he's on YouTube as Storm Center Inc. 1, and I'll put the link to in the show notes that if you want to take a look. And he goes on every once in a while to provide data for you, the public, on YouTube. And he's done it through natural disasters like hurricanes that we had in the fall of 2024. He'll do it again this year. He'll talk about wind patterns, he'll talk about weather patterns, not only just in his area where he lives, but also around the world. All different types of oceans, all different types of geographies. It's amazing, and I can't wait for you to hear this interview with Dave Jones. Here's the interview talking about the National Weather Service, as well as the importance of data when predicting climate and the weather. Enjoy the interview, and I'll talk to you after. Hey, Dave, welcome back to the How to Protect the Ocean podcast. Are you ready to talk about the weather?
Oh, Andrew, I'm always ready to talk about the weather. I eat, sleep, and drink weather.
I love it. I love it. Look, I am so excited that you're on the podcast because we have a lot of questions to ask and to get answered, right? There is a lot of cuts that happened over the last month or so. People are worried about their weather. Are they going to get their weather data? Dave, you provide the weather on a pretty much daily basis to a lot of different organizations, a lot of different, the public, you're on YouTube and so forth. So I thought it would be good to have you on to help answer these questions, help put people's worries at bay, or maybe just be like, no, there's a reason to be worried. Hopefully it's not the case, but we got to talk about it. And I'm so excited to do so today. But before we do, Dave, why don't you just remind people of who you are and what you do?
Oh, sure, Andrew. Yeah, I'm Dave Jones. I'm the CEO and founder of Storm Center Communications. We've been around since 2001. We've done a lot of different things over the years, but what we do now is focus on data sharing and collaboration. We invented a technology called GeoCollaborate, which actually can access trusted data sources from many different platforms and pull them together in a collaborative GIS environment. So what all that means is that we can connect a bunch of people together in a web browser, and we can then move their maps around and display trusted data on their maps, not screen sharing, but actually geospatial data sharing and delivering data right in front of people onto their systems so they can start to use it and understand how that data can be used, to make their operations more efficient, to give them better situational awareness, understand impacts of changing climate or, increased sea levels because of sea level rise and things like that. So I do that. And also, like you said, the YouTube page, I update my YouTube channel for the All Hazards Consortium, which is a nonprofit organization that brings together government organizations like state emergency management professionals, private sector liaisons within those state emergency management agencies, federal emergency management, and also, more importantly, the private sector owner and operators, like from the communications, transportation, medical supply, logistics, energy sectors. So the utility trucks that have to respond to disasters, we provide them with weather briefings, especially when the weather gets exciting and impactful. So they can just, when they're on their way to respond, they can be watching it on their phones or on their tablets. And it kind of brings everybody together in a collaborative, common operating picture, if you will.
That's amazing. Such an important service that you provide. Can you talk a little bit more about you don't have to talk about specific clientele, but who would want this type of weather service? Because obviously, when people look at the weather, they go to their apps and they say, okay, this is what the weather's going to be like. And then they mistrust a little bit and they say, hey, no, that's actually not going to be the weather. If you're on the coast, if you don't like the weather in 5 minutes, it'll change and this and that. But you are providing real time, up to the minute data. And by the way, when you mentioned GIS, that's right down my alleyway. I'm a GIS analyst at heart. So this and looking at, our GIS server and all that kind of stuff, we can geek out about that. But who wants this type of data, this real time type of data?
So, when we talk about the All Hazards Consortium, there's a bunch of different organizations involved. And typically, private sector companies don't like to share information, because they feel like it might get out to competitors and things like that. For example, if a storm comes through and 10 cell towers get knocked over, companies are a little reticent to say, we just lost service in this 200 square mile area. Because then the other companies might say, hey, well, we're putting in temporary ones. We got service, switch to us. So what we typically do is help to provide situational awareness for the general weather that's going on and the impacts that are happening. So we've worked for several decades with NOAA and the Weather Service and NASA. And so we can identify data that might help them in their planning. For example, these highways are flooded currently. We can see it in satellite imagery. We can now look at the projected flood inundation levels and see when those roads might be open. So those utility trucks can get into those neighborhoods, start to assess damage, and start to restore power, restore it quicker. There's a really interesting one. One of the partners that we serve is a very large provider of prescription medications to around the country and around the world. So CVS, Walgreens, all these pharmacies, they get their prescription drugs from this company. They're a logistics and transportation company specializing in medical supplies and drugs. They have warehouses all around the country where they keep these, and then they can distribute them quickly. But if a wildfire develops and the wildfire smoke gets into the warehouse through their air system, and then they go to deliver these prescription medications, the receiving organization, whether it's a hospital or CVS or Walgreens or wherever, can refuse to take delivery of those medications if they smell smoke.
Interesting.
So that puts all those prescription drugs at risk for, having to be thrown away, millions and billions of dollars worth of drugs. So they really never had the ability to identify where wildfire smoke is, where it's heading, and where it might impact some of their facilities.
Of course.
So, it's things like that really
Yeah.
make a difference for these companies.
Now, when you first started, thinking about this service and putting it together with your colleagues, did you ever anticipate the amount of people that would benefit from having this service? Like you probably had some idea of certain people and certain companies that would benefit, but that sounds like a very unique case. I'm sure that it comes up more often than not, but probably something you didn't know right off the bat. You might have known. I didn't know that. I feel that's something that becomes really interesting when you talk about this type of stuff and how many businesses are impacted. But did you expect to help this many types of businesses and clients?
Well, what's really interesting, Andrew, is that when you start to talk and you can get people together, I'm on a telecon with these groups together every Friday. And so, and I've been on them for 9 years.
Yeah.
And so you build up this level of trust where they've now all elected all these, not elected, but the All Hazards Consortium has asked me to chair a committee called the Weather Impacts Committee for all these industries. And so what that really does is it allows us to pull these groups together and say, okay, guys, let's talk about hurricanes right now. What are the important indicators you need to know for you to make decisions?
Mm-hmm.
I mean, for utilities, for example, if they have electric substations that are close to the beach or an ocean or a bay or rivers, and they see forecasted heights of storm surge or flooding heights from rainfall, and they can get that as early as possible, they can move to mitigate potential damage to that substation. And I think that when we first started this out, we knew that weather information could be a very valuable asset and that people probably weren't using it to the best of their ability. And the thing is, it's complex.
Mm-hmm.
It's complicated. It's not a weather app.
No, it definitely isn't.
It's you look at your phone and you see these deterministic forecasts that are 10 days out, and it's not possible. It's not possible.
What do you mean, Dave? Wait a minute. Hold on a second. This is breaking news. You telling me in 10 days from now it's not going to be minus 15 here in Canada? Because that's what it says, and I don't want to see that. I don't want to believe that.
I know. I got just a quick funny story. When I used to do the weather for NBC in Washington, D.C. at NBC4 there for 10 years through the 90s. And this was a January day. I got done with the weather and I had a call in the newsroom. He said, "Hey, Dave, you got a call on line 1." Okay. Pick up the call. And the person says, "Dave, we watch you all the time. You and the whole weather team, you're the most accurate." And I said, "Well, thanks very much. I appreciate that." She says, "Can you tell me what weather you have scheduled in July for my daughter's wedding? Because we need to know if we need to get a canopy or not."
I love how they think that you have this ability to be like, you know what? I think that day is going to be really nice for you. I'm going to make sure of it.
Well, climatology kicked off in my mind, and I said, hazy, hot, and humid with a chance of an afternoon thunderstorm.
Yeah, exactly. Exactly. Yeah, you can pretty much give those predictors and stuff. But yeah, I think it's, but I mean, it's so true though, especially with local news. And I still think this happens to this day with all the different apps that we have for and 24-hour news and stuff. But news, like weather people, like the weatherman, the weatherwoman, and all folks that do the weather, they are a trusted source of people. Like they have you yourself have a great personality. You have this ability to communicate with people, and all the weather people that we see, depending on where they are in the world, they have this ability to communicate people and gain trust. Now, some people lose that trust when the weather doesn't get right and they blame it on the weather person. But for the most part, like, I remember when I was a kid, when the weather person came on, my parents were like, no, we need to know the weather. Like, we need to know that forecast. And like, it's so interesting to see, like, you got like your entire like field. You have to be really great science communicators to be able to do this. You're taking complex information just from a weather perspective for the general public, not what obviously you're doing in Geo Collaborate and Storm Center, but you have to be able to take that complex information and put it into a form where it's like, you're going to like the weather today, or you're not going to like the weather today.
There's always somebody. There's always somebody that's going to say, "Oh, we got a beautiful day in store," and then you get a call and they say, "I'm a farmer. We need rain. It's not a beautiful day."
Yeah, exactly, exactly, right. But how do you develop that? Is that happening during schooling, or is that just like a talent that people are attracted to when they go in this field?
Well, I mean, first of all, there's a couple of questions that you asked there, and they're all really good, and they're ones that are important questions. First, most meteorologists don't go into broadcasting.
Right.
So, it's 1% or less of the meteorologists that graduate are actually on TV communicating the weather to their audience. But those that are on TV are the drivers for that newscast. And what I mean by that is research has showed this over and over again for decades, that local weather is the number one reason why people watch local news.
Mm-hmm.
So they do build that relationship with the broadcast meteorologist, whether it's the morning shift or the afternoon or evening person or the weekend person. I used to go to these events in Washington, D.C., where they'd have the NBC4 tent set up, and, they'd have a couple of, the sports guy and a meteorologist there and an anchor. And people come up to me and say, "Dave, I wake up with you every morning."
Yeah, for sure. It's so weird, right? You're like,
it is. Or you're a lot taller than I thought. So it's like, once you get out of the box of TV, you actually become a real person. But the communication part is really important for scientists, and scientists tend to, it's an intense field. Any kind of science, it's very intricate, it's complex. Some sciences involve a lot of math and physics and things like that. So it's not something you're going to really talk about on TV. Right. And other scientists might work at NASA. They might work at NOAA and doing research, or EPA, or doing air quality. And they're all critical jobs. Yeah. But some of them need a little help in communicating a little bit more effectively. And, we've talked about this and are really talking about it more right now. And that is that communication is so critical to talk about how important things are, because, many TV, this little kind of a pet peeve of mine is that most TV meteorologists and the stations themselves, they'll show a satellite image on the local newscast and they'll call it, News 6 Sky Eye, the radar, digital Doppler XT, like it's a car with leather.
Once you put numbers and letters together, it just, people are like, "Oh, this must be serious.
This is good. This is accurate." I watch that. But what they don't do is say this radar data is from the National Weather Service. Right. And it's important to keep going because we can communicate to you where the storms are. This satellite image is taken from a NOAA satellite that orbits 22,300 miles up in space in a geosynchronous orbit. What's that? Well, you can tell them about that and then say, we need these satellites because we won't see these hurricanes coming without them. And so that's being done maybe less than
So
0.5%
true.
of the time around the nation, probably in Canada as well. And it's really important that that attribution happen, because otherwise people, this was said on the floor of Congress years ago. A certain congressman stood up and said, "Why do we need the National Weather Service when I can turn on the Weather Channel?" You know, and so, my comeback to that is, "Hey,
Duh.
gotcha. Why do we need cows when we can go to the store and buy milk?"
Yeah, exactly.
Right? I mean,
Yeah. The level of like naivete and just
mhm,
ignorance about where data comes from. And I guess it's
yeah,
like we just end up taking it for granted. And I want to take a good chunk of this episode to discuss this. But before I do, I have to ask, like, going back to the weather, the weather people, what short straw do you have to draw to be a weather person that goes out in a hurricane storm and bring it to the people? Like, we know it's bad. Like, why do they subject these poor weather people, sometimes journalists, to putting them out in the middle of a storm? It doesn't matter what type of storms. It could be like a hurricane, it could be like tornado areas, it could be like wildfire areas. Like, why do we do that? Like, what's the point of that?
I don't know. I think stations might just like to bleep out bad words when they, when the winds come or something, and they really want to see you out in the
Right.
elements. And it's like, really? Okay. So the next time a palm frond knocks my head off, make sure you describe to everybody, how it felt, because I won't be able to.
Yeah.
I think, I think there's a benefit for being out to talk to people about why they're not evacuating.
Mm-hmm. Mm-hmm. Mm-hmm.
Why are you going to stay on your sailboat
Right.
at this dock when a 15-foot storm surges?
Yeah.
And you do get people's answers like, "It never hits here.
Yeah.
It always veers, or it always weakens." And then, when you go back and all of their stuff is gone, you can't find the person to interview. Then all of a sudden people are like,
Happens.
"Oh my gosh, they
Yeah, they
they
finally
should
get
have
it.
left."
Yeah, they
But
finally get it, right?
chasing storms is always going to be kind of a ratings driver.
Yeah.
It's dangerous. It's uncertain. Even the best of them get caught sometimes in precarious situations, and it drives ratings.
Yeah.
But the first thing they hear when they get done with a storm is a whole bunch of people leaving messages, or social media posts like, "Why the heck are you there? Why don't you leave?" and all that stuff. So that's an ongoing thing. And
Yeah.
even for storm chasing out in Oklahoma,
Yeah,
I
for the
think
tornado storms. Yeah.
there's legislation that's now being proposed or put together in Oklahoma to only allow licensed meteorologists to chase storms,
Probably smart.
because it's getting kind of crazy out there with accidents and people taking chances, and
Mm-hmm.
unqualified people taking people on tours and making money.
Yeah,
So, we're starting to see some impacts
for sure.
of that happening.
Well, and I think it kind of goes back into, knowing about the data, being qualified to not only know about the data, but also to discuss the data in a way that can be interpreted. But
Yeah.
let's talk about these sources of data that you mentioned earlier. Knowing where this data comes from NOAA, from NASA, from the National Weather Service. These are all very important systems in the government that have
Yeah.
allowed not only the US, but for the rest of the world to benefit from this data and the partnerships that have come from it with other countries, and bring it all together, being able to piece all this data together to get almost a global picture of what's
Yeah.
happening, whether it be satellites from the US, satellites from Canada, satellites from Europe, and so forth. It's been a benefit to the world to have this type of data. Can you talk about, obviously this is leading into government cuts, the recent government cuts, but let's talk about why this data is so important to
Sure.
help protect citizens of the US as well as abroad.
Sure. Well, I mean, let's start with satellites. First, there's two different types of satellites that are up there or orbiting the Earth. One are the geostationary satellites.
Mm-hmm.
They're the ones, and Europe has them, Japan has them, India has them, and they're all orbiting at over the same spot on the Earth. As the Earth rotates, the satellite orbits at the same speed, and so orbital speed, and so they're looking at the same spot at the same, all the time. That allows us to sequence the clouds, put them in a loop, and watch what's moving towards us or away from us. And so these satellites are always monitoring the entire disk, all the hemispheres, northern hemisphere, southern hemisphere, eastern hemisphere, western. And we can see seedlings coming off of Africa that may turn into hurricanes or tropical cyclones. And we can follow them across just by watching them and watching their dynamics, watching how they're developing and all that stuff. Without satellites, we wouldn't know that those systems were out there developing. And we didn't have satellites in 1900. And 1900, there was one of the biggest hurricanes to ever hit the United States, hit Galveston, Texas, killed, some numbers are 6,000, others are 8,000 people. They didn't see it coming, and the storm surge was monstrous. Led to the building of the big seawall in Galveston to protect part of the island. And so these are what we call observing systems. And these observing systems, from a geostationary standpoint, give us a really big, broad picture. There are other satellites called polar orbiting satellites that orbit maybe about 300 miles up. So much lower. They orbit from pole to pole, and the Earth rotates underneath of them. And so they take strips of data. Those satellites are critical because they have different sensors on them that can look through the atmosphere, look at the ocean, take temperature data. They can profile the atmosphere, temperatures at different levels of the atmosphere. And that data is critical for going into numerical weather prediction models. As a matter of fact, 95% of the data that goes into initializing a numerical weather prediction model comes from satellites. So if satellites went away, we'd be in big trouble.
Yeah.
Because, where we don't have a lot of observations is over the ocean. We call them data sparse areas. We have buoys that are out there in the ocean, not everywhere. We have floats called Argo floats. They're at the surface of the ocean, and then they go down about 200 meters, record data. They come back up, and when they hit the surface, they transmit all those observations back. That goes into numerical prediction models, so we can have coupled ocean atmosphere models. There are gliders that go through the ocean that they measure salinity, and they measure temperature and currents, all that stuff as they're going up and down. There's drifters. They're Lagrangian drifters from University of San Diego, California, San Diego. These drifters can be put anywhere, and they just drift with the currents, but they report back wave heights, temperatures, pressures, things like that. And so we use satellite data to estimate what the sea surface temperature is, but we can then use those drifting buoys to validate what those temperatures are, to know that what the satellites are measuring is accurate. And so that's satellites and some ocean observing systems. We also have land observing systems. In the United States, they're called ASOS, Automated Surface Observing Systems, located at a lot of airports, but also in other areas. States are putting in their own meso networks. Meso just means small scale. So small scale networks around the states. And they're taking constant weather observations every minute or less, and sending that data into the National Weather Service. And those states maintain those sensors, they quality control, make sure that the data is accurate. The Weather Service quality controls the data.
Right.
If they say, hey, this temperature saying 80 degrees, but all the other sensors around it are saying 62. Why don't you go out and take a look at it? And so
and just to
that's
interrupt,
important.
these are all around the world. It's not just in American waters. Like they are a number of them in the American waters, but this is all over around the world because everything's connected, right? It's not just here's a 200 nautical mile exclusive economic zone. We're just not going to know data outside of that. That doesn't help in terms of detecting a swell that comes in that may or may not affect the coastal area, or looking at a system that comes in from Africa during the summer and might hit there in the fall, and knowing whether that's going to be a hurricane or not. These are all over the world. There's partnerships with other countries, and this is extremely important data. It's funny. I was watching a TV show, and I know this is a fictional show, but it kind of demonstrated a point of how important data is. And it's a show called High Surf. It's like a rescue show. It's obviously very fictional. It's based in Hawaii. I'm about to go to Hawaii next week. So I decided, well, actually by the time this is published, I'll be in Hawaii, but I want to get ready. I want to see what it was like and everything like that. So obviously I've got a very different illusion of what it really is, but there was an episode where they were expecting like a big swell, like a tsunami, a potential tsunami warning. And they were looking at 3 buoys. It's North Shore of Oahu. And they were looking at 3 buoys that were very far apart from each other and like hours apart, where this swell but they knew the height of the swell after every time it hit the buoy. They knew the speed of the swell, how fast it was coming, and they would be able to detect the change in time and the size and the power of it by the time it hit the next buoy, whether to, go from a warning to, this is a serious threat, or to say, hey, you know what, this is not a warning anymore, we're okay. But the hours in between that to try and get that data was very nerve-wracking. They didn't know what to do. And obviously, it's a show, so they go into all the emotional parts, but it kind of took you through what the different parts of each different part, federal, state, and even local governments were taking, and actions they were taking, and they were relying on this data to come in. Imagine if we didn't have those buoys. Imagine if we didn't have the drifters that were along that may have been in the water at the time that could tell even in between what that is, or even verify that data, or even satellite. We have radar sat that can tell wave height and whether there's something big coming, or you can see a boat in the water or something like that. There's so many pieces of this data that become such an important role. But it also is like there's so much data coming in that you need to interpret it properly. And that requires people with scientific degrees in various science fields, not only biology, but physics and chemistry and atmosphere and so forth, that make the National Weather Service, NOAA, NASA so important. Can you talk about some of the roles that play into that, and the number of people that have to play that role and be able to take in all this data, and what requires the specialties?
Yeah. And let me just mention too, since you were talking about tsunamis, I mean, there are tsunami buoys around the oceans, right? There aren't enough.
Right.
And those tsunami buoys, some of them are far enough out that if an earthquake would happen between the buoy and the coast, you wouldn't detect it.
Right.
And so some of those buoys need to be fixed because they're not working. And so that's why it takes a whole cadre of people to monitor the data. And when something is not reporting, you get out there to fix it. Yeah. And in many cases already, for example, like within NOAA, they're already understaffed. Yeah. And so they'll say, oh, well, we're going to have to take a look at that buoy, in 6 months because we're not going to have this ship that we need to take out. And we'll do a couple of other buoys at the same time. So they're not just going out to look at one buoy and then coming back. That's too expensive for one buoy. So you really do need a whole bunch of people that are monitoring this. I mean, few people can monitor, but you need a whole bunch to go out and fix.
Yeah.
And some of these buoys just aren't breaking on their own, illegal fishing. They tie up to some of these buoys and do these catches with their nets, which they shouldn't be doing.
Right.
Others, sometimes they're a haven for seals or sea lions, and they
Sit
climb
there
up
on
on
it.
there.
Yeah.
And, they're like, hey, why do we have a 15-foot wave out there in the middle of a high pressure system? It shouldn't be happening. You go out there and see it, and it's like a mama seal that made a
It's like
home there. And
half a
he's
ton seal
going
that's
back
just
and forth.
yeah.
All sorts of things can
Yeah.
happen, but you're right, Andrew. I mean, the weather, let's just take a look for a second at the Weather Service.
Right.
The National Weather Service, they have 122 forecast offices around
Wow.
the nation. So it's include Alaska, Hawaii,
Yeah.
Guam, and the CONUS, continental United States. They have 6 regional offices that help to coordinate those local offices. They have 13 river forecast centers that are focused on monitoring the rainfall and river levels, and also doing outreach to people to help them understand how fast rivers can rise. I mean, there are campsites all over the place, and people have no idea. Oh yeah, let's camp by the river over there. It's beautiful. But if there's a 3-inch rainfall out just upriver, and they don't see any rain at all, they could be washed away in a matter of hours. So you need to have that kind of monitoring going on. They also have national centers, 9 of them. So they have the National Center for Environmental Prediction, called NCEP. They do a lot of modeling, and they're kind of the parent center over all the other ones. They have the National Hurricane Center. They have the Weather Prediction Center in College Park, Maryland. The Hurricane Center's in Miami. That's probably the most popular national center that the Weather Service has. They have the Aviation Weather Center. They're constantly focused on aviation and predicting turbulence. Clear air turbulence is so tough, right? They have the Climate Prediction Center. They're looking out beyond 7 days, and they're going into seasonal predictions. What does this spring look like? What does the summer look like? Helping to monitor and predict drought conditions, which are so critical for agriculture. They have the Storm Prediction Center in Norman, Oklahoma. They're focused on severe weather, tornado outbreaks, hail damage, hail size, things like that. The Ocean Prediction Center. They focus on the ocean and getting products out to mariners so they know that big waves are headed their way, or it's going to be treacherous. Here are advisories that we issue for the oceans. They have the National Water Center, which is down in Tuscaloosa, Alabama. It's a fairly new center, but they're working on the national water model, modeling every stream and tributary in the nation, and even in Puerto Rico and Alaska and Hawaii, so they can see, okay, this sensor just measured an inch of rain falling, and so did these other sensors close to it.
Yeah.
We're going to model what the downstream impacts are going to be, so we can warn people that there's a danger if that's going to be any flooding. And then the last but not least national center is the Space Weather Prediction Center. That's in Boulder, Colorado. They're monitoring the sun and the storms that come off the sun and what we call coronal mass ejections, right? CMEs. We've had a lot of experience with those. I mean, the one last May 10th, boy, the Aurora Borealis was visible down in Alabama and Florida and part of the Bahamas, for crying out loud.
Yeah.
That was pretty awesome. So, I mean, people say, well, that's a lot of stuff. I tend to think sometimes, Andrew, that the people just watch too many movies. And, they think that things are operated by AI and shouldn't 1 or 2 people be able to do these jobs. And it's just not possible. It's not possible. The impacts that weather and climate events have had just on the United States alone.
Yeah.
I mean, since 1980, the nation has had, the United States has had 403 disasters that each total $1 billion or more. So since 1980,
Right.
that those disasters have exceeded $2.9 trillion in damage. And so the
And it could have been
investment
worse.
could have been worse.
If they weren't able to get like access to data to understand where these storms are coming from, predicting the
no
levels
doubt.
of the storms and so forth, right? Could have been worse.
No doubt, no doubt.
Yeah.
And you know, when you think of the investment that's needed for the National Weather Service,
Yeah.
and you boil it down, because the Weather Service forecasts impact every person, right? All the planes that are coming in and bringing people in internationally, domestically, for transportation. If you boil it down, it's for the price of like a Big Mac or a Happy Meal, you know, per American. It's like $10, $12 per person per year that funds the operations of NOAA. And so when you turn around and you look at cuts, and you know might do cuts, implement cuts randomly, you could cut out the people who are hired to warn you if a tornado is coming. That's going to cost lives.
Yeah.
Yeah.
Yeah. And it's so important. I don't understand the pushback on this type of data. And the pushback that I'm talking about is over the last month, since the Trump administration has taken over power, and they're Donald Trump's now the president, Doge has become a thing. Elon Musk is going into a number of different offices, say either closing down the entire department like he did with USAID, but also going into other departments and just doing mass cuts, not only to the people of the public service that we just talked about in terms of what it requires and the people it requires, and even being understaffed, but they would cut just people randomly. And we're hearing stories by the day. At this point, the last story I heard is, Elon Musk sends a mass email to a number of people in the government saying, what have you done in the last five things you did this week? If you do not email me back, consider it a resignation. Still not sure if that's true or not. There's been a lot of stuff that's been going around, but talking to fellow colleagues in NOAA, at EPA, in a number of different departments, they're scared. They're worried. They're worried for their colleagues. They're worried for themselves. So obviously there's that portion of it, but there is this fundamental attack against getting information from the environment about the environment, to the point now where we've seen a lot of cuts that have happened on international programs. And this is where I really wanted to focus the rest of the episode, and we've been kind of building up to it, is there have been cuts to any international programs for NOAA, which include the National Weather Service, in gathering data beyond the borders of the U.S. Can I ask you, David, and I don't even know if all the information has been divulged in terms of what part of those programs are going to be cut, but can you give us just a little bit of enlightenment of what this means for weather predictions, what this means for climate predictions, all the different centers that you mentioned? What does this mean going forward for the U.S.?
Well, I think, Andrew, if data flow was cut off between internationally, between nations, it would seriously impact the ability to forecast accurately. I mean, when I give talks, I talk about the 5-day forecast, or the 7-day forecast. The 7-day forecast today is as accurate as a 3-day forecast was 25 years ago. Okay, so we're improving in our forecast accuracy. There's a couple reasons for that. We're having more sophisticated physics-based models that are processing more data. We're not using all the data that's being collected yet. There are still what's called data assimilation efforts to bring in different types of data, even data from the private sector, if they're launching, satellites and are collecting data and information. But what it requires is a global data set that you're reading into that model in order to sufficiently initialize it, right? I mean, I don't know if you've heard the term garbage in, garbage out,
Yeah. Okay.
right? If you are putting in less data or non-quality controlled data because you laid off people that are quality controlling,
Yeah.
that means more bad data will get into the model, and that means the output is going to be bad and get worse as time goes out, right? So that's an issue. I have heard of some meetings, being delayed or canceled internationally, but I haven't heard of anything related to stopping the data flow
Mm-hmm.
and the data sharing when it comes to forecasting,
Right. Okay.
because that would be really impactful.
Yeah.
Not only for the average citizen that wants to make a decision, but I mentioned all those centers from the Weather
Yeah.
Service, the Aviation Prediction Center, right? The Weather
Yeah.
Center, Aviation Weather Center. If you and there are meteorologists at all these FAA locations, which are trying to help planes navigate safely. There could be a lot of impact to aviation, maybe more flights
Yeah.
canceled, more flights delayed, things like that. They just can't handle the capacity without knowing
Yep.
what weather is in front of them, how long things are going to last. So it would have a serious snowball effect on not only the impact of people, but impact to the entire economy around the globe. All the economies around the world would be impacted.
Yeah. And from what I've heard as well is, and I don't know if this is true or not, there have been some jobs and programs cut and then they've been reinstated, or they hire back the people because the government realizes that some of these programs are vital. Hopefully, if it hasn't been cut and it doesn't get cut, people realize how important it is. I mean, we've just discussed how integrated knowing the data that comes in for predicting weather is good for aviation, it's good for fishing fleets, it's good for cruise liners, it's good for just, farmers and anybody who requires any type
Yeah.
of natural input to their products or services is going to need this data. Like, I really don't see the need to cut any of these programs because of how vital it is. Now, one thing you've mentioned a number of times in this episode is the fact that these models are so important. Modeling is such an important part of the Weather Service. Now, I have been hearing a lot of people talk about how fraudulent these models are, how inaccurate these models are. That seems to be the driving narrative when it comes to whether it be climate models or weather models or anything like that.
Mm-hmm.
Obviously, they're not fraudulent. I'm joking here, but this is what we hear. And you've been hearing it too. Everybody's been talking about it, from government officials, like new government officials, all the way down to just the common person on the street, just being like, these are fraudulent. Every time I mention, climate change, I did an episode about the cuts to NOAA and talking about the Weather Service, and everybody's saying NOAA sold out and took money, and NASA did the same thing to, continue the climate fraudulent sort of things and all these fraudulent models. None of them are true. Of course, none of them provided evidence about how untrue they were or how fraudulent they were. But it seems to be the narrative of a lot of people. And
Yeah.
I don't think it's shared just by one party or another. I think there's a lot of people who think that these models are fraudulent. Dave, you've discussed this a number of times, not only on this program when you came on with the wonderful Ellen Progler about your book, Megalodons, Mermaids, and Climate Change. There's a constant battle of misinformation when it comes to science, especially when it comes to weather, climate change prediction models, and everything like that. How do you combat this? How do you say, no, these aren't fraudulent? How do you prove that they're not?
Well, I think, it's always an important conversation to have because, weather and observing and, predicting is very complex, right? It's a high order magnitude of complexity, and it's not for everybody. And so what people want to hear is it's going to be sunny and 74 4 days out, and the predictability of the atmosphere is not that accurate when you have to go out 5, 10, 15 days and try to give somebody what we call a deterministic forecast. We're determining it's going to be 74 with a west wind at 3 miles an hour, and then they remember that. So what happens with a lot of folks who, and I've had it too, people say, what do you do? Oh, I'm a meteorologist. Oh,
Yeah.
I wish I could be right 50% of the time and still get paid. Right. So that one always pops up.
Yeah.
But by the way, major leaguers make it into the Hall of Fame with less than a 300 batting average.
Hey, that's a good point. I like that.
And make
rebuttal.
millions, and meteorologists don't make millions.
No,
that's for sure.
Exactly.
But when you talk about forecasting and people not believing, if they're serious about wanting to understand how models work, and I have the saying that every model is wrong.
Right.
It's just how much.
Yeah.
How
sure.
wrong are they? And models, the way I grew up and studied, and I used to work when I was a student at University of Maryland. I would work. I had a job at NASA Goddard Space Flight Center. I worked in the global modeling and simulation division, where I assisted scientists in satellite retrievals to see if satellite data could improve models.
Right.
And so I think that some people just don't understand that we need those observing systems to go into a model. And what models give us is guidance. They give the meteorologists guidance, right? It's like, okay, it looks like this low is going to move along the south and come up and intensify, and we might have, 6 to 10 inches of snow because of that, and the winds are going to get really strong. The model, and there are a lot of models out there, so many so now that they pull them together in what's called an ensemble. Right? An ensemble is a whole bunch of things coming together, right? Just like a outfit. You put a whole ensemble together. In modeling, an ensemble might have 50 members, which means 50 different models, all with different physics, tweaks, things like that.
Yep.
And then they average that out and bring out a new forecast. And so that it's hopeful that an ensemble forecast is more accurate than any individual model. And so when it comes down to people, I think, even over the years, thinking that weather forecasting has not gotten any more accurate, it has gotten worse. It's because, let's say, for example, let's go back to that question when the lady called me when I was at NBC in Washington in the 90s and said, you guys are so accurate. What weather, she said, do you have scheduled 6 months from now? Well, first, we don't schedule the weather. We can look at climatology and see what it might be. But what they do is, if, like, for example, you're on the way to Hawaii, and you look at the forecast last week.
Yes.
You say, oh, it's going to be, look at that beautiful wind at 2 miles an hour coming off. It's going to be 81 degrees. That is awesome. And you don't look at the forecast again until you're coming in for a landing.
Right.
Right. So that might be 7, 10 days. So what people tend to do, which, it's not a crime, it's natural behavior, is you anchor to that forecast. It's called anchoring.
Yeah.
And if you have a special event, a wedding next Saturday, oh, what to plan? Well, I got to plan what to wear. It looks like 76 and sunny 7 days ahead of time. And you don't look at the forecast again because you think that's what it's going to be. Then you get there and it's an easterly wind. It's 52 degrees. There's drizzle. And you're like, what the heck? Those forecasters are never right. My app stinks, And so you have to keep updated on the weather when the forecast, gets closer, right? When that special day gets closer, you need to monitor the forecast. Why do you have to do that? Because observations come in that detect certain things happening, maybe 5,000 miles away.
Yeah.
That might kick off the model and say, oh, wait a minute.
Something's up.
This might develop into a low pressure system downwind and develop into something that could be significant or impact the forecast. So just one little mention. There's a professor named Edward Lorenz, who was at MIT, and he wrote a paper called "Could the flap of a butterfly's wings in Brazil cause a tornado in Texas?" And that paper was all about what's called chaos theory.
Yeah.
Can one little disturbance grow and kick off other things that then create something else that leads to a severe weather outbreak? And it's, the basis of modeling, really. How can you predict chaos? That's why the forecast is very tough. We're pretty good out to 7 days, but these apps, they're all automated. They're using one model. They're giving numbers to make it look like they're more accurate. I have a daughter that tells me, "Dad, why is it snowing? My app said it was going to be sunny." And I look at the radar and say, "Oh, it's just a little flurry moving through." But I guess your app didn't say that.
No, exactly. We depend on it so much, right?
Exactly right. You're right. It comes because it's just so darn convenient to be able to look at something and get an answer, but it doesn't mean that answer is correct. And so when you asked about how do you battle that misinformation, you just do it by engaging people where they are. Ellen Prager and I, we love engaging people when they want to complain about the weather or the ocean, atmosphere, or whatever. And we say, well, what's your beef?
Yeah.
What's going on? And they say, well, it's just, all this talk about climate change. It's just not, it doesn't mean anything. It's all made up so scientists can make a lot of money. And we don't make a lot of money.
What? Wait. I got into this to make a lot of money. How come I'm not making a lot of money here, Dave? What's going on?
I know. Maybe if the currency was, slaps on the back or something, we'd have more.
Exactly.
But so, what we do is we say, well, what have you noticed over the years? What do you do? Oh, I'm a farmer. I'm a lobsterman. I'm a fisherman.
Yeah.
Well, have you noticed anything? It's like, the fish are all south, or the fish are going further north, and we have to go further and use more fuel to get them.
Yep.
Oh, well, why do you think they might be going north? Are they being chased by mean fish, or maybe they're sensitive to temperature?
Yeah.
And that temperature is warming.
Yeah.
And there's a reason that temperature is warming. And so you can take them down a path that they're cool with. We're not showing any differential equations. We're not showing any, integrals. No. We're just saying, look, animals aren't dumb. They're going to go where the food is.
Yeah.
And if the temperature changes and their food goes north, they're going to go north.
Right.
And it's all because the temperature is rising. And it's a very simple concept if you break it down to that.
Yeah.
That we have not had any dismissive people that we've engaged in conversations with when we just talk to them about what they do and what are they seeing, and just Well, I mean, one last one. We were in Florida last week. We gave some talks about our book. One was at the Harbor Branch Oceanographic
Oh yeah.
Institute, and the other one was the Florida Oceanographic Society. They both said they were both record attendance, which was awesome. That was
That's
great hearing.
fantastic.
But we were sitting, at the hotel, and there was a guy sitting there, and we were just talking to him, and he ended up he's windsurfs, and he windsurfs on those really cool new windsurf boards that raise up, and they're like look like they're hovering above the ground, but it's a little like wing underneath.
Yep.
So it's very cool.
It is.
And so he was just talking to us, and he was telling us about all these things. What he's really there to build a house, and he's building a house on a beach there in Florida. And we were like, oh, that's cool. He's like, oh, I got all these permits, I'm waiting on and all this stuff. And we're like, oh, are you building it to, withstand any storms or anything like that? And he's like, I'm just, we're putting in the standard stuff, and, I'm going to sell it and, I guess make a lot of money and all that stuff. And we didn't tell him a thing about, who we were, what we were doing, and all that stuff. We just had a good conversation with him. We understood that he wasn't really very knowledgeable about weather or the oceans. And then he finally said, well, what do you guys do? And so we said, well, Ellen's a marine scientist and I'm a meteorologist. Really? And so we ended up talking, and we said, yeah, we're here to give talks about it, but we wrote a book on atmosphere and oceans and climate change and impacts and stuff like that. And after about 45 minutes, he's like, I got a lot of learning to do. He said, I have a lot of learning to do. And he said, I got to tell you guys something. He said, you have all my respect. He said, you heard me go on and on and on and on, and you didn't interrupt me once and tell me, no, you're wrong because of this, or you're wrong because of that. You just engaged in a conversation.
Yeah.
And so he took a picture of the book. He said, I'm going to get it. I'm going to read it.
Nice.
And, I hope to learn stuff from it. And
it's a great marketing plan.
It doesn't have to be an argument,
I think you're right. And I think that's the fundamental problem that happens when we start having these so-called discussions online. There's this stereotype that scientists are elitists, that scientists think they know more than everybody else, and they're just going to tell you how it is. And to be honest, there is some merit in that in the past, where, scientists would come into a community, or they would come into a talk, and they would say, this is how it is. And if somebody came up and said, well, I don't believe it, and then it was like an argument back and forth. And I really like your approach, where you just engage in conversations with people. They are people, and they want to enjoy a good life. We all want to have a good life. We all want to be safe. We want to survive we want to live as long as possible. We don't want to see our houses flooded. We don't want to see our houses burnt down. Nobody wants to see that. And I feel like, all this stuff about climate and the climate change and, sea level rise and so forth has become so politicized, and the political divide has increased so much that it's become argumentative. And to agree, I've been doing that too at times. You get emotional when you hear a response, you take it personally, and you're like, no, like, dummy, this is the way it is. And if you respond that way, you're going to get the same kind of response back, in terms of it's going to be aggressive. But if you just kind of have a conversation, like, what do you do for a living? Oh, I want to know, how do you notice like anything change? Like, just like this story with, like the fisherman, like, okay, so what, have you noticed your lobster, being harder to catch? Or like, what have you found out there? Because obviously the fishing community has been able to tell more than we've been able to do as scientists, because they're out there all the time. The indigenous communities have been able to tell us more about what's been happening to their land over, hundreds, if not thousands of years, because they've been seeing it, and they are so in tune with the environment. Yeah, we need as a scientific, society, as scientists, to listen more and to engage in conversations instead of just dictating what it needs to be. And I really like that approach. And then you offer a resource, just like your book, The Megalodons, Mermaids, and Climate Change. Like, offer that resource after, and be like, hey, if you want to know more, there you go, it's right there. And if you want to know more, you can find out more. There's always resources available, and scientists are always willing to talk as long as
Yeah.
it's in a comfortable situation, a calm situation, and nothing aggressive, right?
Well, and it gets back to our conversation too at the beginning of this, where scientists are not the best communicators.
Right.
And I remember back in 1995, 96 timeframe when Dan Golden was the administrator of NASA at the time, and he was very big on scientists being able to communicate the work that they're doing. So much so, he went to Goddard Space Flight Center and gave a talk, and he said to the scientists, if you can't describe to me in 3 minutes what you're doing and why it's important, you're not going to get funded next year.
Right.
And so, that really, we better learn how to describe what we're doing.
Yeah.
A lot of people know it as the elevator speech,
yes.
right?
Yes.
You got to give that elevator speech. But it's very important. But what I think is really even more critical for scientists is to listen.
Mm-hmm.
Scientists tend to want to get all of their knowledge and their PhD thesis out, over a restaurant table and or over a drink, and they're not listening to what the person is saying,
Mm-hmm.
and they're not gauging, the level of interest and or education of the person that they're talking to. And you should just really have a conversation like you're not that scientist, but just bring in pieces of that science when it's relevant, when it
100%.
means something. And that seems to be, make a big impact. And
Yeah.
I think it gets, the conversation gets political. I think many times when you start talking about the causes of
Yes.
climate change,
Yes.
right? What's causing it. And that in itself is still a simple physics problem. It's, you could have a closed container and you could put more CO2 into it and it's going to heat up when the sun hits it, right? In your little experiment, it's going to happen. It's a physics problem.
Yeah.
So when you do it on the globe, more CO2 in the atmosphere is causing the warmth.
Yeah.
So that's not a debatable piece of science itself. But then when you get all, how do you stop it? How do you, ease it? Can we ease out of it? All that kind of stuff is when, things start to diverge.
Yeah.
But we're really all about talking about impacts of a changing climate and how is climate change either energizing systems to become more extreme or stacking the dice so those events happen more frequently.
Mm-hmm.
Mm-hmm. Flooding in
Yeah.
Western North Carolina from Hurricane Helene.
Mm-hmm.
Never seen anything like that before in their history, of recorded history.
Yeah. And they weren't prepared for the damage either, right?
They weren't prepared for it. And many people said, we're 26 feet above the water. Look, it's just a stream down there. Why do we have to worry about that? And all of a sudden the water comes up 30 feet.
Yeah.
So there's a lot of understanding that needs to happen between people who just normally have sunny weather and what extremes could happen.
Yeah.
And whether they want to accept that level of risk or not. And so really with extreme weather becoming more frequent, people just have to look at where they live, their neighborhoods and things like that and say, okay, well, let's go through some scenarios of what could happen.
Yeah.
I mean, we live in an area where it's really never major flood before, but we bought flood insurance.
Yeah.
And it's cheap and it's gonna cover a lot of property damage if it happens.
And I like that idea. It's just, you can move into an area. How much risk are you willing to take? Are you willing to move into an area that has a potential to be, exposed to wildfires or to flooding, and may or may not have insurance available for it, or it might be extremely expensive. Are you willing to risk that? If you are, That's your prerogative. You're allowed to do that. That's your right. You can go ahead and do that. Unfortunately, that there's some areas have higher risk than others. And if you want to believe the models, you want to believe the data, that's
Yeah.
up to you. And then you can avoid that. Nobody wants to see anybody get impacted by this stuff. But it's also,
That's right.
there's data out there to kind of show where there's less risk, and that will be through insurance agencies, that will be like, and prices, that'll be
Yeah.
through NOAA and local government actions of looking at floodplains and so forth, and to look at what risk you're in. And it's just a matter of keeping it available. Now, one thing that you do, Dave, is you go on YouTube every so often, on a fairly regular basis, and also during times where there are hurricanes or major storms or major wind patterns or major meteorological events. One of those was during the fall. I saw you a number of times, not only on LinkedIn, but on YouTube. Like, I think it was just being put up everywhere, where you were discussing how these hurricanes, one after one, were coming, one after the other, coming in, and what kind of impact it was going to do, or what is the predicted, where it's going to go, why it shifted, and so forth. Providing that data to people who need it or who have it. What was the response like to people who watched it or commented, that kind of stuff?
Yeah, no, Andrew, thanks for that question, because we were probably just as surprised as anybody else to see what the reactions were, and we have been doing YouTube updates, but more on the private channel side, right. So just sharing the link, and only people with the link could watch it, and that was for the All Hazards Consortium, to help for the movement of fleet utility vehicles across the country to restore power and things like that. But then, before Hurricane Helene formed, we opened up those briefings to the public. And, we're not out to get views. We're out to provide a service to the people who wanted those videos. And we had like 520 subscribers at that point in time. But when Helene hit and we opened it up to the public, people started seeing those videos, and I don't know if it was the algorithm or what, but YouTube was recommending the video to people who were searching for weather or the hurricane or things like that. And we went from 520 subscribers to 17,500 subscribers in about 7 days.
Yeah, that's unheard of.
And it was just incredible. I mean, I'm not one that really dives into YouTube analytics and says, oh yeah, okay, well, I got 700 views or whatever. I mean, my daughter called me and said, Dad, I'm sitting here watching your subscriptions go from 10,000 to 12 to 15 to 16. And, we had millions, 4.3 million views on those hurricane updates. But what was most exciting to us about was that, and I still don't understand the ratio of likes or dislikes or whatever, but the likes are always between 97 and 100%. And the comments came in by the thousands.
Yeah.
People saying, thank you for helping us understand what's happening with the storm, why we need these observing systems like the buoys in the ocean, what the satellites do. People are commenting on the Terminator line of the sun setting, and you can see the shadow coming across the world. I've never seen that before. We could see the sunset.
It's science live, like pretty much recorded in for you, and you never know what to expect of what you're going to cover.
Yes. And so what we really did is we took that, and we had so many thank yous from people watching in Japan or Australia and saying, we have family on the west coast of Florida. We're telling them to watch this, and it was like, okay, that was a wake up moment for us, thinking okay, we're just doing these videos to help all hazards and then putting it out there for other people who might be interested.
Yeah.
But now, I mean, you get comments back like, this is the best weather channel I have ever seen. Thank you. And we're not doing it every day, but we're doing it when, things happen, and, we're hoping to ramp it up to do it more frequently, but we do want to make sure that the video is educational at the same time it's useful for people to improve their situational awareness, or to learn why am I even able to do these videos, right? We have video recording technology. We're using some right now to do the podcast, but how in the world can I show you a global satellite image that's updating every 10 minutes? How can I zoom in with GeoCollaborate and show you what the wave heights are, 50 miles off of Tampa?
Yeah.
How is that even possible? And this is why I think it's so important to explain the technology that's able to make that happen, and to make sure people don't understand that, okay, you might have just watched this sci-fi video on Netflix or this movie about spies and all the data that they seem to have and be able to process, which you can't do that fast today. It's all Hollywood. But we can bring this data together for you for a very little bit of investment from the American taxpayer, and help you keep informed of what's going on, not only around the country, but around the world. And so, I think with all the talk of these cuts and, major realignment of the U.S. government, as long as you do that, understanding what you're cutting, and not just cutting people for the sake of cutting people, that will go a much further distance with the American people, and also with those people who are benefiting from these technologies. Because, again, if we cut out weather data and the data flow, or you just say NOAA's going to collect the data and then give it to the private sector, there are different jobs and roles that the government has versus what a private sector company has. The private sector has to make money, so they're going to charge for things. And the government agency is a public good. It's a service. So, a lot of people say, give it over, give it out, do all that stuff. But if they just took the time to understand the significance and the billions of dollars that have gone into the satellite platforms that are operating, takes people sitting at those controls 100%. To make sure if something happens, they put it into safe mode, or they keep it operating, so it doesn't fall out of the sky or do reentry. That all of this data is been decades and decades of the weather enterprise working together, listening to each other, and really putting forth great products that both the private sector can make money on and the government can stand behind. And the That's biggest concern I have is if the forecast, everything goes over to the private sector. Is that if I give you a forecast for a water taxi going across the harbor in Honolulu, and a thunderstorm comes and a gust front tips over that water taxi and kills people, are you going to sue me for giving you a forecast that didn't include that thunderstorm? I think if that ultimately is what happens, where the weather enterprise goes because of these changes, the public, the private sector organizations will quickly go out of business, because they will not be able to take on that liability. And the government has always been protected from that liability.
And 100%. And obviously they help more people than the people get harmed. This has been a phenomenal chat, Dave. I knew this was an episode that you and I could talk for so long on, because it's such an interesting topic and it's such an important aspect. And I really want to thank you for coming on the show today to start talking about really understanding why this data is so important, and why we really can't live without it, and what the consequences could be if this data starts getting cut. Obviously, I hope it doesn't. I love what you're doing with Storm Center. I'm going to put links to all the website, the YouTube channel, so people can take a look and really learn. You're such a good teacher on these episodes. I know I learn stuff all the time when I watch it. I have it on in the background when I'm working and I'm watching. It's really interesting. So, I really appreciate what you're doing. Obviously you and Ellen with the book, and I'll put the link so that people can get access to the book as well, to learn more about the ocean and the weather and climate, and just, more about our planet, such an important role, and why we need this type of data. So Dave, thank you so much for coming on the podcast. Love to have you back to talk more about weather and climate. And until next time, thank you so much.
Oh, that'd be great. I mean, look, my biggest fear is we go back to 1900 with no satellites, and we have a landfalling hurricane that kills 15 or 20,000 people.
Yeah.
We don't want to go back there. And Andrew, I'd love to come on and talk to you about weather all the time.
Absolutely. Wonderful. Thank you so much.
Okay. Take care.
Thank you, Dave, for joining us on today's episode of the How to Protect the Ocean podcast. Like I said before, folks, you learn so much when you hear from Dave. He has such a great approach to talking about the ocean. It's magnificent. That's how I'm going to describe it. It's magnificent. He and his cohort and partner, Ellen Prager, who have a book called Megalodons, Mermaids, and Climate Change. The book is out now. Answers to your ocean and atmosphere questions. It's basically tackling misinformation and just general questions that people have on the ocean and the atmosphere. If you want to learn more about those things, you buy this book. I'm going to put a link in the show notes. I highly recommend it. It's just a great book, non-politicized, just about the science. You get to have fun learning about our planet, learning about its environment, and learning how we can predict the weather and the climate, as well as ocean patterns. It's always fun to be there. And Dave is such an interesting science communicator. He's so engaging. He's got such an emotional tie to his voice. It's always positive and uplifting. I really enjoy it. And if you want to check him out on YouTube, I'll put the links in the show notes. But if you have any questions or comments about the episode, you can get a hold of me by DMing me on Instagram at How to Protect the Ocean. That's at How to Protect the Ocean. Don't forget to subscribe to this YouTube channel, as well as hit that notification bell so you get information about the ocean, marine biology, animals, Monday, Wednesdays, and Fridays every week. I can't wait to provide that for you. But that's it for today's episode. Really appreciate Dave coming on the podcast. We'll definitely have him back to talk more about the weather and more about data and how important it is. But I want to thank you for joining us on today's episode of the How to Protect the Ocean podcast. I'm your host, Andrew Lewin, from the True North Strong and Free. Have a great day. We'll talk to you next time, and happy conservation.